Hello everyone. In this session, we will try to discuss about the control of the structure. In the previous session, what we have discussed is with respect to the biomimetics. See, the biomimetics, as we know that it is a combination of the biology and as well as engineering indirectly. But in this case, in this what we are discussing is with respect to how the structures it should be controlled. If you want to have the control on the structures, the loop system is a major factor. Either it should be a closed loop system or it may be an open loop system. In categorizing the smart structure as a open loop or a closed loop, we have implied that a small some are capable of responding actively to the changes and the state or the environment, for example by altering their effective mechanical properties. Much of this is devoted to analyze means for sensing or including the mechanical phenomena such as the forces displacement are often through by using the electrical signaling mechanisms. In this session, we shall consider the devices and as well as the subsystems that generate the signal to which the actuator responds, and this effect they produce some common configurations. In a closed loop structures, the sensors outputs are produced by the controller and the generates the actuator commands. In a open loop structures, they may employ neither the sensors nor the actuators. On the other hand, nothing prevents the use of the actuator without feedback. Such open loop smart structures will need a control to generate the signal applied to its structure. Thus, the closed loop smart structures requires a controller, while an open loop structures may or may not incorporate it. We will be concerned here the primarily with the feedback systems that the closed loop structures have. It will come as no surprise that the introduction of the feedback can radically alter the dynamic of the structural systems and affecting the natural frequencies and as well as the mode and its a transient response and even its stability. Fortunately, it is a studying of the smart structure we can take the advantage of these literatures and in the field of the structural control, which has matured greatly over the last 2 decades. Much of this work has dealt the conventional structures modified by means of the addition of the discrete sensors or it may be the actuators as opposed to move fully a integrated system and implied by means of the terms of the smart structure, but it has gone far towards connecting the some points and dissipated the field and as well as structural dynamics and the control theory. Now here in this case, in the previous cases what we have discussed is with respect to the control of the structures. These structures can be controlled either by means of the closed loop system or it may be the open loop system. If the structures is under the closed loop system, it is very easy to control the structure, but if the open loop systems, the actuators are very difficult to actuate and as well as to control the system. For that reason only, here we are how to do the analysis with respect to the structure as a controlled plants. We consider a section some points that must be addressed in applying the automatic control techniques to alter and as well as the dynamic response of the structure. Our focus is those the features of the structural dynamic models and as well as distinguish them from more typically the plant and thus the potentially the complicated control problems. The analysis of the plant is not so easy. Here in the case of the analysis of the plant, the so many static and as well as the dynamic loads are coming into it. The same way, even with respect to the structural problems also, the static and as well as the dynamic loads are coming to it. And once if these parameters are in the plant is easily analyzed, the same way the structure also the dynamic and as well as the static parameters can be easily analyzed and we can minimize the structural failures. The modeling of the structural for the control. In discussing the control theory in the abstract, it is common that assume that our availability of the model of the plant to be controlled, typically in the form of a differential equations or the inputs. For many purposes, number of inputs and as well as the outputs or the number of the states can be regarded as a parameter that defines the case by case. The basic and as well as the theoretical development that can proceed under the assumption that the number is small and senses the sheer size and as well as the metrics to be manipulated with the present to the no numerical difficulties. This approach may work well in the case of the mechanical systems with a few degrees of freedom and even the bearing in the mind that each degree of the freedom gives rise to a two state of variables. One is the displacement, the another one is nothing but a velocity. However, it is common to perform the static and as well as a dynamic analysis of the structure with a many degrees of freedom. When the structural dynamic model results from a finite element discretization, a large complex structure, it generates a 10 to 10 thousands of degrees of freedom. Although the numerical method to compute the natural frequencies and as well as the natural modes, such systems are available. The computational tool of the modern control cannot all be expected to be as so as robot. The consequence of this disparity is that the straightforward the reduction of the even the moderate structural model of the state variables from a produced to a state of space model uh, ungainly dimension. This has motivation of the interest in reducing the size of the structural models while retaining the acceptable accuracies. In the exploiting of the structure, the equation governing and as well as a mechanical system plays a major role. The idea behind the model reduction and as well as the reduced order modeling is to identify those degrees of freedom and as well as a state of variable at least relevant to the goals. In this process is discussed is the most control and as well as the text and also the many of the finite element methods which gives a very clear description and as well as a brief example. The directional equation that governs the multi-degree freedom in the case of the mechanical system that tends to be a precedable structure is nothing but mx double dot as a function of t and cx dot as a function of t and kx as a function of t is equal to f of t, where k are the static and positive definite and c is a symmetric and as well as a positively a semi-defined. There are certainly other forms of equations of the motion, such as those the gyroscopic and as well as the circulatory systems, but the structures of those forms is often similarly regular. In natural to exploit as such features, the second order governing equations developed by the first order state variable models. There has no there has also been interest in the developing and controlling the theory directly in terms of the second order Planck equation, taking the advantages and as well as the features of the symmetry. Particularly, the challenging for the standing point of the modeling are those the mechanical system with infinitely many degrees of freedom, that is structure is idealized to a continuum.